Next topic is equilibrium constant from Nernst equation. Now this is the equation for the Daniell cell, reaction taking place in the Daniell cell. As the reaction takes place and time passes, concentration of Zn2 plus ion increases and concentration of Cu2 plus ions decreases. At the same time, voltage of the cell also decreases. After some time, it is seen that there is no change in the concentration of Cu2 plus and Zn2 plus ions, and at the same time voltage is 0. This indicates that equilibrium has been attained. Now in this situation the Nernst equation may be written as, now since the equilibrium is attained and voltage is 0, E cell will be equal to 0. So E cell is equal to 0 and E cell is also equal to E naught cell minus 2.303 RT by 2F log concentration of zinc ions divided by concentration of Cu2 plus ions. Now since E cell is 0, rearranging this equation, E naught cell is equal to 2.303 RT by 2F log concentration of zinc ions divided by concentration of copper ions. Concentration of product divided by concentration of reactant is equal to equilibrium constant. At 298 Kelvin, putting the value of R, temperature equals to 298 Kelvin, value of Faraday constant is 96500 coulomb, 2.303 RT by F is equal to 0.059. So the equation becomes standard reduction potential is equal to 0.059 by 2 log Kc. Now value of E naught cell is equal to 1.1 volt. Putting the value of E naught cell, log Kc can be calculated, and from the value of log Kc, value of Kc, that is equilibrium constant for the reaction taking place in the Daniell cell, can be calculated. In general, the value of standard electrode potential is equal to 2.303 RT by NF log of equilibrium constant value. So equilibrium constant of the reaction, difficult to measure otherwise, can be calculated from the corresponding electrode potential value of the cell. So this is the utility of this equation. Now calculate the equilibrium constant for the reaction. Now this is the reaction. If in general it is difficult to calculate the equilibrium constant for this reaction, then knowing the E naught cell value for this reaction, equilibrium constant can be calculated. E naught cell is equal to 0.059 divided by number of electrons involved in this reaction is 2. Copper gives 2 electrons and changes to Cu2 plus ion, and 2 moles of silver ion accepts 2 electron, changes to 2 moles of silver atoms or solid silver. So number of electrons involved is 2. So E naught cell is equal to 0.059 by 2 log of equilibrium constant value, and this is equal to 0.46 volt. From this, log Kc can be calculated and it is equal to 15.6. Taking anti-log, value of equilibrium constant is equal to 3.92 into 10 to the power 15. Next topic is electrochemical cell and Gibbs energy of the reaction. Electrical work done in 1 second is equal to electrical potential multiplied by total charge passed. Work done is equal to total charge passed multiplied by potential difference. To obtain maximum work from a galvanic cell, charge has to be passed reversibly. The reversible work done by a galvanic cell is equal to decrease in its Gibbs energy, and therefore if the EMF of the cell is E and NF is the amount of charge passed, means N into F gives the total charge passed, then the value of Gibbs energy for the reaction will be equal to minus N into F into E. What is F? It is charge carried by 1 mole of electrons, which is equal to 96500 coulomb. What is N? N is the number of moles of electron which participated in the reaction. So total charge will be equal to moles of electron multiplied by charge carried by 1 mole of electron, or this can also be written as N into F, and multiplying the total charge, that is N into F, by EMF of the cell will give the electrical work done in 1 second, or it is also written as delta G for the reaction. Now since the work is the reversible work done, it is equal to decrease in the Gibbs energy. Therefore, it can be written as delta G is equal to minus NFE. So this is the expression obtained, delta G is equal to minus NFE. E cell is an intensive parameter and delta G is extensive thermodynamic property. And the value of delta G depends upon N. Means in this reaction value of N is 2. That is number of electrons participating in the reaction is 2. So value of delta G is equal to minus 2 into F into E. But when this whole equation is multiplied by 2, value of N becomes 4. That is total electrons taking part in the reaction becomes 4. 1 mole of Cu2 plus changing into Cu. The moles of electron accepted by Cu2 plus is 2 moles. 1 mole of Cu2 plus accepts 2 moles of electron to change into 1 mole of copper. And when this entire equation is multiplied by 2, then this equation becomes 2 moles of Cu2 plus ions plus 4 moles of electron forming 4 moles of Cu. So here the moles of electron is 4. So value of N becomes 4. Therefore delta G value also becomes minus 4 into F into E. If the concentration of all the reacting species is unity, then E cell is equal to E naught cell. And we have delta G naught is equal to minus N into F into E naught cell. E cell is equal to E naught cell minus 0.059 by 2 log Zn2 plus divided by Cu2 plus. Then if concentration of all the reacting species is 1m, means concentration of zinc ions is 1m, concentration of copper ions is 1m, then log 1 to the base 10 is 0. This expression becomes equal to 0 and E cell becomes equal to E naught cell. So delta G naught is equal to minus NF E naught cell. Thus from the measurement of E naught cell, we can obtain an important thermodynamic quantity, that is delta G naught, that is the standard Gibbs energy of the reaction. From the standard Gibbs energy of the reaction, we can calculate equilibrium constant by the equation standard Gibbs energy of reaction is equal to minus RT natural log of K, or this can also be written as standard Gibbs energy of the reaction is equal to minus 2.303 RT log K. This is log to the base 10. Example, the standard electrode potential for Daniell cell is 1.1 volt. Calculate the standard Gibbs energy for the reaction. Standard Gibbs energy is equal to minus N into F into standard electrode potential. Putting the value of N, which is equal to 2, F, which is equal to 96487 coulomb per mole, E naught cell is given as 1.1 volt. Solving, value of standard Gibbs energy is minus 212.27 kilojoule per mole.